Good morning, students. In this video, we are going to discuss about Module 3 of Computer Organization and Architecture. The topic of this module is nothing but input-output organization. So, how effectively the computer is going to be get interconnected with the input-output devices, how this data are going to be get transferred from input device to processor or from processor to output device. Those things are going to be get detailedly described in this particular module. Let us enter into the module. Actually, the input output organization has its basic features of exchanging the data with the other devices. How this data is going to be exchanged between a computer, that is going to be dealt in a descriptive manner in this particular module. The computer enables a human operator to use a keyboard and a display screen to process a text or a graphic informations. As well, computers are an integral part of a home appliances, maybe a manufacturing equipment or a transportation system, a braking system, and a point of sale terminals. Input to a computer may be from a sensor. It may be a sensor switch or a digital camera, a microphone, or a fire alarm system, etc. Output may be a sound signal to be sent to a speakers or a digitally coded command to change the speed of a motor or to open a valve or to cause or to move a movement in a specific manner. Maybe a robot, so we can make the instructions can be given to the robot to move towards left or right or top, front or back. Such a way the computer is going to give the sound signal or a electric signal which can be given to the external devices. In short, a general purpose computer should be able to exchange the information with a wide range of devices in varying environments. Such things are going to be discussed detailedly in this particular module, input output organization. So as per the syllabus, we are going to see about the first topic is going to be called as accessing IO devices. What actually an accessing IO devices? A single bus structure can be used for connecting input output devices to a computer. Each IO devices is assigned to a unique set of address. We're going to have a bus which may consist of three set of lines to carry an address, a data, and a control signals. When a processor places an address on an address line, the intended device responds to the command. The processor requests either a read or a write operation. So the requested data can be transferred over the data line. So this is going to be called as an accessing of IO devices. Let us see a simplified diagram which can specify clearly about the particular architecture. So if you're going to see about the IO device which may consist of a processor, a memory, and a multiple number of IO devices may be connected. All these are going to be connected through a bus. There are two ways to deal the IO devices, whether it may be an memory mapped IO or IO mapped IO. So let us see about that one. A multiple IO devices may be connected to the processor and the memory may be via a bus. So sometimes what happened, the devices, the IO device may be an keyboard or a scanner, maybe a multiple devices may be connected into a particular computer. To access these IO devices, obviously the processor places an address on the address line. So the device recognizes the address and responds to the particular control signal. In such a way, it's going to be doing its process. So to deal this particular instructions, the two IO devices are going to be there. So one is going to be called as a memory mapped IO and second is IO mapped IO. What actually a memory mapped IO? A memory and a IO devices shares a common address space. Any data transfer instructions like a move or load can be used to exchange this information. For example, we're going to have a data in, comma or not. This instruction sends the content of a location data in to register or not. Here, the data in address of the input buffer of the keyboard. Such a way it's going to do the memory mapped IO. And we're going to move to the IO device, which is going to be IO mapped IO. A memory and IO address spaces are different over here. So both are having a different addresses. A special instruction named in or out, maybe in or out, are used for the data transfer. Advantages of this separate IO space is nothing but which can deal with fewer address lines. So here the IO interface is going to be taken care in a different way. How it's going to be get IO device is going to be interfacing this IO input devices, which is maybe with the help of three things. One is going to be called as address decoder, second control circuit, third data and status register. What actually the address decoder is going to do? Address decoder enables the device to recognize its address when this address appears on the address line. Whereas the status register, which is going to be used over there to contain the information relevant to the operation of IO devices. What kind of operation is going to be performed in this particular interface instruction? That such signal is going to be get stored in the status register. Then the data register holds the data being transferred to or from the processor. There are two types of data going to be present over there. One is going to be called as data in and second is going to be called as data out. Let us see about those things. So as I have said that the three buses are going to be present. One is for address line, one is for data line, one more is going to be for control line. And this is going to be a IO interface which consisting of an input device which is going to be communicating to this particular buses through the address decoder, control circuit and data and status register. What actually the IO devices is going to do, we have come across over there, that the data in and data out, the two important buffers which are going to be placed over there. This data in is nothing but an input buffer which is going to be associated with the keyboard, and data out is nothing but the buffer which is going to be associated with the display or a printer, an output device which is going to be used over there. Okay, such a way these IO devices are going to be accessing the data from the input to processor via output to processor to output. What is the synchronization? Recall that the rate of transfer to an or from IO device is lower than the speed of the processor. This creates the need for mechanism to synchronize the data between them, because the processor is going to run in a different speed, the input device may be in a different data rate. If both are going to be in different data rate, what happened, the execution may not be get processed in time and the outcome may be delayed over there. To overcome this problem, we are going to make a mechanism which is going to synchronize the IO devices and the processor. So due to the synchronization, what happened, actually the process is going to be done very quickly and the outcome is going to be given to the output device as per the estimated time. Such a way we are going to do a process that is going to be called as synchronization. The synchronization can be get done in three ways. One is going to be program controlled IO through interrupts and direct memory access. What actually it's going to do that one? The programmed IO, the three techniques which have been possible over there. The three techniques, the first is going to be called as a programmed IO. Data are exchanged between the processor and the IO module. In this programmed IO, the data are going to be exchanged between the processor and the IO module. Processor executes a program that gives its direct control to the IO operation. When the processor issues a command, it must wait until the IO operation is going to be get completed. If the processor is faster than the IO module, this is wasteful of process time. Hence, we need this synchronization over there. Next one, interrupt driven IO. Processor issues an IO command which continues to execute other instruction and it is interrupted by IO module. When the later has completed its work, it's going to resume that. So here also synchronization going to be get needed over there. And third mechanism which is going to be called as hardware control or a direct memory access. In this, the IO module and main memory exchanges data directly without the involvement of the processor. Such a way we are going to do that one. Let us see about one by one. First one, the mechanism which is used for interfacing IO devices. First one, program controlled IO. A processor repeatedly checks status flag to achieve the required synchronization between the processor and IO devices. We can say that the processor polls the device. That's nothing but it's going to give the instruction to the processor that the data is going to be get ready to do the process. So the ready signal will be given over there. So by this, what happens, the main drawback when you're going to see about this, the processor waste time is in checking the status of the device for actual data transfer taking place. Each and every time the processor needs to go over there and check for the buffer whether it's going to be filled or not. Those time is going to be get wasted over there. This is the main drawback of this program control IO. Let us see about how the connection is going to be get connected to the processor, a general purpose processor which consisting of a control register, and the keyboard which consisting of a data bus, status bus, and control registers are going to be present. As like that, the display also going to have a data, control, and status bus. The interface is going to be present like this, and all this are going to be connected to an interconnection network. Here in this interconnection network, it's going to take place and it's going to be connecting the input from the data buffer to the general purpose register, as well as from the control register or general purpose register to the data of the display buffer. Such a way it's going to do its process. Let's see about the second one, interrupt IO. The IO devices which initiates the action instead of the processor. Here the IO device sends an INTR signal, nothing but the interrupt request signal, over a bus. Whenever it is ready for a data transfer operation, it's going to do it requires a synchronization which is going to be done by the processor and IO devices. Such a way it's going to do its process.